Hey kiddos, in this video we'll be going over Unit 6, Lesson 5, so 6.5. So in your notebook, go ahead and please write in the top left-hand corner 6.5. Our aim for today is we want to be able to solve problems using the tape diagram again, similar to what we did in the last video. I'm hoping this model of using tape diagram by tomorrow or by the next lesson that we do, you'll understand why we're using the tape model so that you won't need to use it as often. But it's just going to be a tool that you'll have in your math toolbox, if you will, in order to be able to solve these types of questions. Similar to the last lesson, there are a couple things that we want to keep in mind. There's some vocabulary that we want to remember. So when we're talking about ratios, ratio is just a comparison of a pair of non-negative numbers. So quantity A compared to quantity B. And we know that the ratios can be alike or the ratios can be different. When we talk about terms, that's one part of the ratio. So each of the terms are going to be represented like we saw in our last video and like we're going to talk about today. We're talking about two different terms because these are the two different things that are going to be compared to one another. We can have like quantities when we're comparing same units, boys to girls, both of them are people. Unlike quantities, dollars per gallon, laps per minute, they're not the same. And then finally, equivalent ratios. That's when two ratios express the same relationship between two terms. And then our model for today, as it was with the last lesson, is a tape diagram. And a tape diagram is used to represent equivalent ratios that have the same units. So let's take a look at, once again, reviewing what our criteria for success are, the things that we want to just keep in mind so that we are able to answer the question, being able to attack these questions and in such a way that leads to us being able to answer them. So number one is we want to make sure that we're annotating. Number two, we have our model. And then number three, we're going to want to make sure that we're answering whatever question we're being asked. So when we read these questions, ask yourself, number one, what am I comparing? Those are the things that I should be annotating. Number two, does your model, our tape diagram in this example, does it mirror what you just annotated? And then number three, are we answering whatever we're being asked? Let's see. Question number one, and I think about a question. So you got your notebook open and you're writing this down in your notebook. It says that the Holiday Inn caters to people who travel for different types of business trips. On a Saturday night, there's not a lot of business. So the ratio of the number of occupied rooms, we're going to annotate that, to, so we see this is what we're comparing, occupied rooms to the number of unoccupied rooms. So I'm going to say occupied is O, and then C is for, not C. I'm going to use the letter U for unoccupied. That it is 2 to 5. So occupied 2, unoccupied 1, 2, 3, 4, 5. If we're told if the Holiday Inn had 360 unoccupied rooms on Saturday night, how many of the rooms were occupied? So we're told that these 5 pieces of tape is equal to 360. Well, how would we figure out what one piece of tape is equal to so that we could then figure out what the number of occupied rooms is? Well, we take this 360 divided by 5. And that gives us 72. So that means each one of these pieces of tape is equal to 72. Well, for the occupied rooms, if 2 of the pieces of tape is equal to 72, to figure out what the total is, it's 72 times 2, which is 144. So how many rooms were occupied? 144. Did we annotate? Check. Did we have a model? Check. Did we answer the question? How many rooms were occupied? Yes. Check. Bet. Let's move on to the next one. On Sunday night, the ratio of the number of occupied rooms, so now it's changed, the number of occupied rooms to the number of unoccupied rooms, so that part is still the same, occupied to unoccupied, changed to be 6 to 1. So now occupied, 1, 2, 3, 4, 5 to 1, due to the number of business people attending a large conference in the area. How many occupied rooms were there on a Sunday night? So based off of what we just seen in this question, what do we see? Well, we see that the total number of parts here, there is 1, 2, 3, 4, 5, 6, 7 parts. And here in our second question, we see once again there's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Oh, 6. There we go. And that last one makes 7 parts because it's 6 to 1. So the total number of parts hasn't changed. So that means the total number of people hasn't changed. What has changed, though, is previously in the last question, we saw that there were more unoccupied versus occupied, and now there are more occupied versus occupied. So that means the pieces of tape are still going to represent the same number of people, but now the total is going to be different for each of the occupied versus unoccupied. Whereas before, it was 7 times 2 for the occupied. Now it's going to be 72 times 6. Because that's the ratio of 6 occupied to 1 unoccupied. 1, 2, 3, 4, 5, 6. Yep. 72, 43, 432 people. Whereas there was just 72 people. So we see here that the total number of parts, total number of pieces of tape, as we saw in our diagram, that still stayed the same. So we know that each part in the ratio should still also stay the same. There's just a change in the total number of occupied and unoccupied rooms. What's the same in both of these two ratios? Well, we see the thing that's the same is the total number of pieces of tape, meaning the total number of people who were at this Holiday Inn over the weekend. What has changed, though, is the number of people who were occupying a room, meaning they stayed at that Holiday Inn, versus unoccupied rooms that were not. What can we take away from this? Well, we can take away that a model can really help us see the before and after parts of a question. We see that a model can really help us better understand or visualize what the question is asking us. So with this in mind, and with our 3 key points or our 3 steps, criteria for success that we have right here, let's see if we can use that in the next question and the other lessons for today, or the questions for today. Let's take a look at question number 1. It says, Peter is trying to work out by completing sit-ups and push-ups in order to gain muscle mass. Originally, Peter was completing 5 sit-ups for every 3 push-ups. So, number 1, annotate. What are we comparing here? We see it just told us 5 sit-ups for every 3 push-ups. So we're going to say sit-ups, push-ups, and we see it's 1, 2, 3, 4, 5 sit-ups for every 1, 2, 3 push-ups. But then Peter injured his shoulder. After the injury, Peter completed the same amount of exercises as he did before, but completed 7 sit-ups for every 1 push-up. So 1, 2, 3, 4, 5, 6, 7 for every 1 push-up. During a training session before his injury, so this is the before, and this is the after, Peter completed 27 push-ups. How many more sit-ups was he completing after his injury? So before, the total number of push-ups was 27. And we can see that before the ratio was 1, 2, 3, 4, 5 sit-ups for every 1, 2, 3 push-ups. If this was 27, what would one of these pieces of tape represent? Well, 27 divided by 3 is equal to 9. So that means there was 9, 9, 9. Each one of these pieces of tape is equal to 9. If we look at the total pieces of the number of tape, 1, 2, 3, 4, 5, 6, 7, 8, 8 pieces of tape here, and we see 8 pieces of tape in our after as well. What do the pieces of tape represent? Well, they're still going to be representing 9, either sit-ups or push-ups, except now the total number for The sit-ups goes up, whereas the push-ups go down due to the injury that Peter sustained. And now we've done step 1, annotate. We've done step 2 with our model. Step 3 is make sure that we're answering the question. And the question was, how many more sit-ups was he completing after his injury than before? Well, after 1, 2, 3, 4, 5, 6, 7. 9 times 7 is 63. That was after. Before was 1, 2, 3, 4, 5. 9 times 5 is equal to 45. We want to see how much more than. He's completing 18 more sit-ups than he was before. And hopefully we can clearly see that with our 1, 2, 3, 4, 5. 2 extra pieces of tape, which help us see that each shape is equal to 9, and 2 groups of tape of 9 is equal to 19, 18. Mr. Pierce getting tongue-tied. Excellent. So following these 3 steps once again, our annotations, our model, and then finally, are we answering the question? We can clearly see in this particular question how Peter was completing 18 more sit-ups after his injury than he was before. Great. Move on to the next page or the next part of your notebook. This will be the last thing that we're going to do together before you'll be back in class working with your partners. We see that Tom and Rob are brothers who like to make bets about the outcomes of different contests between them. Before the last bet, the ratio of the amount of Tom's money, so here are 2 quantities, annotating Tom and Rob. So Tom and Rob. We see the total amount, the amount of Tom's money to the amount of Rob's money was 4-7. So Tom, 1, 2, 3, 4. Rob, 1, 2, 3, 4, 5, 6, 7. If Rob has $427, how much money did Tom have? Well, 1, 2, 3, 4, 5, 6, 7. So 427 divided by 7 is equal to 61. So that means each one of these is equal to $61. If there's 4 pieces of tape here, and each one represents $61, that means Tom has $244. Once again, how do we get that? Rob, we see he has 7 pieces of tape here. That's represented in our diagram. He has a total amount of $427. When we divide 427 by 7, that gives us 61. So that means each one of these pieces of tape is equal to 61. And so if we do 61 times 4, that's where we get the $244 for Tom. Part B says, Rob lost the latest competition, and now the ratio of the amount of Tom's money to the amount of Rob's money is 8-3. So once again, Tom's money, Rob's money, now it's 8. 1, 2, 3, 4, 5, 6, 7, 8. To Rob's money is 1, 2, 3. How much money does Rob have now that he's lost the bet? Well, the total number for each piece of tape is still going to be the same, 61, because we can see that the total number of pieces of tape, 4 plus 7 is equal to 11 pieces. So our total is still 11, or our total is 11 here. Here, the total is 11 pieces as well. So each one of these is $61, $61, $61. So 61 times 3, that's equal to $183. And then 61 times 8, that's equal to $488. So how much money does Rob now have? Rob now is down to $183. Excellent. Please make sure that this is in your notebook as well. Let's move on to partner practice in class.